So this is the second video on linear relations and patterns. And in the first one, we were looking at how we could take a number pattern and convert it into a rule. So for this second video, we're going to be looking at how we can take the rule and then convert it into a picture, which is what it would look like when we were adding it to a graph. So in our first video, we looked at creating an equation kind of like this one, 2x plus 3. And what this would tell us is that this is actually an increasing pattern because there's a 2 in front of the x, which meant that whatever the numbers were in this pattern, I know that they were increasing by 2 each time. So how do we get to looking at what it looks like, what its picture is? So if we start, we can create what's called a table of values. And the x column is going to deal with what we refer to as our input numbers. We used it from our previous video as being the number in our first position, second position, third position. So it actually gave everybody an order. So we're going to do the same thing. We're going to do first number, second number, third number, and fourth number in our pattern. But now we're just going to make use of the rule because it actually tells us what to do. It's kind of like a recipe. So this says 2 times the input number. So in the first case, it's 2 times 1. Plus 3 is going to give me the output or the y value. So this is going to be 2 plus 3, which is just equal to 5. So that tells me that the 1 for this particular pattern, or the first number in our pattern, was actually a 5. And then we're going to reuse the pattern or rule, and we're just going to replace the 1 with a 2 this time. And we're going to get 4 plus 3, so this time 2 goes with 7. And we're just going to repeat the process with every input number that is in our table of values. We're getting to practice BEDMAS as we're doing this. So 3 is going to go with 9. And the last one, when we put in 4, we have 8 plus 3, so we end up with 11. And it's interesting to note at this point that our pattern does indeed go up by 2, which is kind of what we expected when we looked at the original equation. So now we can take a look at each one of these, and they actually create a coordinate. And I know you guys have done graphing, but just as a quick reminder, the first number is our x value, and our second number is our y value. The x value gives us directions moving left or right, and our second coordinate or second part of the coordinate gives us the up-down. So in this particular case, the point 1, 5 would be starting at the center over 1 and up 5. The second one is over 2 and up 7. And the third one is over 3 and up 9. Now, unfortunately, the fourth one, 4 and 11, is off the side of our grid, so we don't need to worry about adding that on there. And then with a ruler, we would just go and connect them, and that's visually what that particular pattern will look like when we put it onto a piece of graph paper. All right, so for this second one, I will give you, I'll probably give you a minute. So if you want to just hit pause and onto a piece of paper, if you could fill in the table of values, I will suggest let's just use 1, 2, 3, and 4, and I'd like you to work out the y values. And when you're ready, come on back and we'll check how you did. All right, welcome back. So we're going to be checking and figuring out what the y values are for each of these using the rule that is given. So again, when we take a look at this, I see that the leading coefficient is -3. This actually tells me that my pattern is actually one that's decreasing. It's going from higher numbers to lower numbers, and I can tell that just by looking at the coefficient. So I'm going to use the rule and insert my input number to figure out my output number. And this first one should go with the number 1. Again, we repeat ourselves using the new input number of 2. And we get -2. And we're repeating again. So you get to reuse it as many times as you need, as many times as you have numbers in your table of values. So we have -5. And then the last one, inserting 4, and we get -12 plus 4, so that's -8. And then as a quick check, I'm going to check between each of these, and I do notice that they're going down 3 each time, so I feel pretty good about the math that I've done. So again, each one of these is a coordinate. So I am just going to rewrite them as coordinates so I can actually see the XY values together in the brackets. And now I can graph them, each one individually. So 1, 1 will go right here. 2, -2. Okay, so we're going down into quadrant 4. 3 goes down to 5, -5. 1, 2, 3, 4, 5 is right there. And this time our fourth one actually does fit on here. 6, 7, 8. So when I connect those, and again on a piece of graph paper, you would probably just have a ruler. I'm just doing it freehand, so it doesn't look as great as it could. But again, those all line up. And so that helps us understand why we call them linear, because the idea of lines. So they're linear patterns because when I put them on a grid, they all line up. All right. Now this last one that we're going to take a look at is kind of interesting because it has a fraction. And a lot of times when we see fractions, it kind of throws us off here a little bit. So we just have to be really clear on what's happening here. We're going to be taking the x value. We are multiplying it with the 1. And this number on the bottom is actually a divide number. So we just have to keep in mind that when we're doing this, we're just going to be doing a little bit of dividing when we make use of this rule. All right, so we can just get started. Now we can use 1, 2, 3, and 4, and just like we've been doing before, and start filling this in. Now you may notice when we fill this in, when we go 1 times 1 divided by 2, we end up with a fraction. So graphing fractions is a little bit challenging because we know it's somewhere in between. So we actually, we can either go all the way along with this one and figure this one out, or we could just move on to the next number and find one that actually does divide nicely. This one is okay. I mean, 1/2 take away 3, we could do a little bit of math here. There's going to be -2.5, but it's a little bit challenging to graph this one, so it's not really my favorite. Now, if we go to the next input number, when I multiply, I get 2 divided by 2. And I actually quite like that a lot better because 2 divided by 2 gives me 1, and 1 minus 3 is equal to -2. So I actually can graph this one. The first one, a little bit harder to do it accurately. And so when I put 3 in, I'm going to have 3 divided by 2, which once again doesn't divide nicely. So you know what? I'm going to skip that this time. And I'm just going to go right on to 4 because I do notice that 4, when I multiply here, I get 4 divided by 2, which actually works out to be a nice integer value, and we get -1. So I like this one, but I'm going to say I want at least one more point. I like having 3 dots at least to connect together. So when I go and think about what another possible input number is, I'm really just wanting, I wonder if you notice here, the 2 and the 4 both worked really, really well. So I wonder if you have an idea of other numbers that might also give us a nice integer answer at the end. Think about that for a second. What number would you use? Now, I think I'm going to use 6. Because I kind of noticed something here. I noticed that this is a 2 and this is a 4. There's almost a pattern within a pattern here of numbers that work out nicely. So this is going to be 1/2 multiplied with 6 minus 3. And again, when I do the multiplying, I get 6 divided by 2, or 3 minus 3. Oh, that gives me 0. That's definitely a nice point to graph for it. Okay, so when I go to take a look at this one, this time I'm going to go over 2 and down 2. There's my first coordinate. Over 4 and down 1. And over 6 and down 0. And once again, they all line up. So I feel really good about the math that I've done. And that's what that linear relation looks like. All right, so now your turn to, I realize many of you aren't going to have graph papers. So I'm just going to get you to fill in the table of values and identify what the y values are that go with the x's. Now we'll start off with 1, 2, 3, and 4. And for this last one, because there's a fraction, I would like you to try and pick 3 numbers that would work really nicely in that formula. So why don't you hit pause, Go do those and then come on back. All right, welcome back. So you have filled in your chart. So I'm going to look at this first one. If I put 1 in here and do the math, I've got 5 take away 7. I'm just going to write it here so I can see that. So that's -2. And when I put 2 in for x, I'm going to have 10 minus 7. So that's giving me 3. And when I put 3 in there, I'm going to have 15 take away 7, which is 8. And when I put 4 in there, I've got 20 minus 7 is 13. So there would be the coordinates for what I would put on a piece of graph paper to be able to see what 5x minus 7 looks like. In the second case, we are putting in, again, I've just chosen 1, 2, 3, 4. And again, I'm choosing those numbers because they're nice and easy, and also that there are no fractions in my equation. So those are good choices. So I'm going to have -3 plus 1. So we've got -2, -6 plus 1, which is -5, -9 plus 1, which is -8, and -12 plus 1, which is -11. So those would be the coordinates that I would need for this second one. And then the last one, because I end up having to divide by 3, I want to make some really good choices here about what numbers I'm using. So I want to choose numbers that divide by 3 nicely. So 3 is a really good choice, and I'll show you why. If you multiply by 3, again, I'm multiplying here, so this is going to give me 6 divided by 3. This works out perfectly. I'm going to get 2 plus 5, so this will be 7. Let's see, my next number that I know that divides nicely by 3 is 6. So I'm going to have 2/3 times 6 this time. Multiply those. I've got 12 divided by 3, which is 4. And 4 plus 5 is 9. Now, I actually am going to sneak in one here that you might be a little bit surprised about, but I'm going to actually use 0. And 0 is quite interesting because take a look what happens when you multiply by 0. So if I multiply these two, I get 0 divided by 3, and 0 divided by anything is just 0, so I get 5. Now, many of you probably chose 9, and I think that's a great choice. That one would have given you, let's just do a quick check. This is going to give you 18 divided by 3. So we've got 6 plus 5, which is 11. So again, you've got 4 points that you can put on a grid and connect together to be able to see what the picture looks like. All right, thanks for watching. Have a great day.